So just so it's been shown, there's our homework for tonight. I don't know if do we have anyone absent today?
No.
No? Good, sweet. So, this Cavalari's, I always say that wrong, Cavalari's principle states that if two space figure meaning a three-dimensional object, have the same height and same cross-section at every level, they must have the same volume. So the cross-sectional area is like when you slice through something. So if you take a three-dimensional object and slice right through the middle of it. So if you think about like us, if you slice right through horizontally, you're going to get like a spine, maybe a spleen, maybe a liver, a few things. If you slice vertically, if you like, has anyone been to the Bodies exhibit?
No.
I've still not been able to go. Not that they had like an installment of it, but Bodies is like a traveling thing. They had one over at Easton. So they literally have human cadavers, like real human bodies, that they've like sliced straight down the middle, straight across, and you can see all like the systems of the body.
Real human bodies.
Real human cadavers. Yeah, real human bodies.
Kill you. No, they're already dead.
They're already dead.
My fifth grade science teacher is a cadaver. Like she signed up to be one.
Yeah, well, so I don't know if I can be a cadaver and so I'm like a organ donor. So like when I'm dead, I don't need my body. So I've signed up to donate everything, all my organs, all my tissue, whatever you can use, take it. You want my eyeballs? Take my eyeballs. Like seriously, like. So you got to think about the greater good of humanity when you become an adult and you make those choices for yourself. Because I don't want a casket or anything like that. So it's kind of like it's a waste of money to spend money on someone who's dead. Just take my body and help other people. So that's the Bodies exhibit. People signed up and they said, okay, take my body and help for science. So when we talk about cross sections, that's kind of what we're looking at. Is if you were to slice vertically through it, or horizontally, or sometimes we slice diagonally, which gets even more challenging. Volume of a prism, very simple formula. A prism is like taking a building floor by floor by floor. It's exactly the same the whole way that you go up. Every floor that you go up increases by that scale factor of that much volume in it. So we take the area of the base, which we always call our big B, and we just multiply by the height because that's just how many stacks it has. Volume of a cylinder, the same thing, except now think about that base area just being round and stacking that on top of each other. So you can think of like a stack of quarters or any kind of round object stacked up. What would be the volume? Well, take however many layers you have times the volume of the base. So I just realized I need to capture all these. Anybody have any big issues on the homework last night? I had a couple people come see me and ask some questions.
Yeah, stayed until 11 finishing it.
I apologize. How was your concert?
Okay.
Okay.
Oh,
It took me like 43 minutes.
The what? Question?
So on the ones that you have to rotate around the...
Yeah, I don't understand.
All right, let's talk about those as soon as we get through this.
I just have to confirm with you about something.
What, they make cylinders?
I thought the last two.
Hey, I can't hear Jacob.
So on the last two, it says rotate around y equals 5
And then-
x equals 2.
Actually, I don't think the y equals is 5, but yeah, I think the y equals is 2, and the x equals is 3.
Y is 5, X is 2.
Maybe I'm thinking of whatever one you asked me about, I think I'm thinking of a different problem. All right, go ahead.
Y is 2,
So-
X is 3.
The thing is, it's like the inverse. It's kind of like they took the code out of the cylinder, and so would you just add the
So here you're having a misconception. So y equals and x equals make vertical or horizontal lines. So a y equals line is a horizontal line. So if you had a y equals and you had a shape like this, and your line was at the top of it, then your object would rotate like this and make the cylinder. But if it's in the middle of the object, like y equals, and it's in the middle, it makes a cylinder, but only with the height of the distance of that rectangle. So I'll pull it up at the end of the lesson. We should be able to get through this lesson pretty quick. So we can review last night's homework here in a minute. Leon?
Okay, so for the questions Jacob was talking about, like 23 and 24,
Yeah.
I don't really know how to classify the shapes. I kind of wrote cylinder minus.
Cylinder with whatever characteristics. So cylinder like with height of this and radius
I
of
just
this.
wrote cylinder minus cone.
So remember the height is always the distance between the bases. So let's get through this real quick and then we'll talk about
In this
So we have a prism here. Base dimensions of 24 and 20, and then height of 10. Now here is where you can kind of choose what's length and width and height on your own, but as we know, prisms are pretty easy. We just multiply two of them together and then multiply by the third. So you can really just multiply them in any order. So if I did my 20 times my 10 first, because those numbers are easy to multiply together, what's 20 times 10? 200. So then I'm going to have 200 times 24. So when you think about this, I would seriously write out 10 times 20 times 24. That becomes 200 times 24. So I double that. And I keep my number of zeros. And then my label, centimeters cubed, because now we're dealing with volume.
I got it right. Hey, about being dead, Mr. Hudson.
Huh?
Is it considered selfish if you were cryogenically frozen under the hope that one day they can resurrect people?
Yes.
It's cryogenically frozen, but I mean, it depends on what you define selfish to be. That's all very like, I can't really answer that question.
Shellfish. Mr. Hudson, the reason
Gonna get you fired, Mr.
bad,
Hudson.
shellfish, like, you would rather donate your body parts to someone than have
Put
them
trash
like
in the ground.
decaying and being
Yeah.
eaten alive.
Yeah, something in the ground that doesn't ever break down. Try this on your own. Raise your hand when you're done. Try this on your own. Raise your hand when you're done.
Which one?
They got it. Boom, 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 boom. What's the volume? 60 feet cubed. It's not right if it doesn't have a label. I'm going to say this again so you hear it. It's not right if it doesn't have a label. So on the mastery, if you just give me numbers, I'm going to mark it wrong. And you're going to get frustrated and be like, but I did. Yeah, if you don't give me the label, it's wrong. And I may write like dogs, cats, pizzas, question mark, because if it doesn't have a label, we don't know what you're talking about.
60 dogs. No, 60
Turtles.
The volume is 60 turtles. Like, yeah, that doesn't make any sense. All right, so cylinders, slightly different. Area of the base is now a little bit harder, and order matters here a little bit more than before. Sorry, we're not to cylinders yet. I jumped to the next section. So here, area of the base, again, though, everything I just said for circles does hold true, because to find the base area, again, your base has to have identical on both ends. So although it doesn't look like the base is in the side that's down, my base here is the triangle. So to find the area of that triangle, we need 1/2 of the base of the triangle times the height of the triangle, not the height of the prism. So what's the problem with that for us here? You don't have the height. So we end up breaking it down into two isosceles triangles. Where are you? Sorry, yeah. Not. Does it say equilateral? Yeah, because you can see 8 and 8 here, and then 8 right here. So that tells you it's equilateral. So then I can split that into right triangles. I can use trig, or I can use the Pythagorean theorem. So if I had 8 squared minus 4 squared, well, 8 squared is 64. 4 squared is, so we're going to have 64 minus 16 equals 48. So then we have to do radical. Huh?
You could just use 30, 60, 90.
Ah, it's a 30, 60, 90, and it already actually popped up. I didn't mean to go this far. So your long leg is radical 3 times your short leg. Guys, some of you are forgetting that. I remember it as if there's a 30-degree angle, that clues my brain into radical 3. So when there's a 30-degree angle, your long leg is radical 3 times your short leg. And we, of course, put the 4 in front to make it look nicer. So we now have that height is 4 radical 3. So we set up the base as 1/2 of the little b times the height. I end up, when I do that math, to get 16 radical 3. I then take that and multiply by the height of the prism, distance between the bases, which is 10. So when I multiply that by 10, I just get, really? It's just 10 times the 16. So it's 160 radical 3, approximately 277.
No, it's not. It's 160 radical 3 inches. Inches.
It's
cubed.
old.
But still, how does
Greg.
It loses the moisture inside of it.
Oh, can I like go like?
How are erasers
I've got some pencils back in the jar. Salsa jar back there.
I got
Is
you.
this stuff to ponder or is this
Do you
bad?
want this one home?
I don't know. He was just asking. So try this on your own. You're luckily given the height here.
Really? I'm sorry, it's too late. I've already done it. Mr. Hudson.
If it can't
Yeah.
be.
Ooh, here, throw it. Let me see if I
Oh,
can.
never mind. My bad.
Or not.
I'm
Okay,
scared.
fine.
You know what? I'm gonna hold the head all the
One
way.
hand.
What are you, Mr. Hudson? Are you good?
I'm good now.
He was like reaching back for my face.
Do you have like every single color of pants?
Turquoise, mint, and orange.
You have using 5 terms when you have units.
Oh, and the red ones.
Do you have
big
big chocolate
pants.
chip pants?
I told Marika I want a pair of pants like hers, where it's like checkered on the one side. and-
Marika has awesome pants.
Yeah.
She does.
All right, what is our volume up here? Hit me with it.
Somebody hit him with a number.
I forgot to put the units.
150 meters cubed.
Hey, do you have the Rex Kwando pants?
Yeah, you should get the Rex. You should get Rex Kwando pants. No, Rex Kwando, the guy from Napoleon Dynamite. Aren't those supposed to be American? Yes, go. Mr. Hudson, you should still get Rex Kwando.
Okay, cylinders. We're trying to get through this quickly so you guys can do your homework and I can help you with last night's homework. Our base here, pi r squared. They like to play some tricks sometimes, so be careful that what they've given you is the radius. So we get 9 pi for our base. We then take that, because volume will be the big B times the height. Nine times 8 gives me 72. So we get 72 pi, or approximately 72 times pi. In terms of pi, we can leave it there then.
I hate when it does that because then it feels so wrong saying pi so you just.
226.
So the big reason we do that sometimes, so the reason we leave things in terms of pi is when I get my answer not in terms of pi, it is approximate. It is not, even if I write the decimals of 0.19467, there's still more decimals after that because pi goes on forever. So we can never exactly represent the volume unless we use terms of pi. That's why we do it. I know, like, starting out it feels a little bit wrong, but a lot of times when we work with terms in pi, we end up having other terms in pi and they work well together.
So being
As opposed to having lots of approximate values that as we go, the error becomes larger and larger and larger.
This is really clear.
It is.
It's very helpful.
I figured it'd be a nice reprieve from all the intense stuff we've been
Is
doing.
2 meters the diameter of the
Give me the height.
Yeah, so here's where they're trying to trick you. 2 meters is the diameter, but you don't know the height of the cylinder here. So you need to figure out the height of the cylinder.
But so it's not.
How can we figure out the height of the cylinder? Jacob, you got an idea?
So you draw down a line to the, like, you draw a line down, and because it's a right angle, you figure out that that other segment is also 2 meters.
So I can move that there to kind of see what Jacob's telling us.
Yeah.
The distance between here and there is 2.
So, and then you can use Pythagorean theorem to find out that the hypotenuse of that is square root of 13. Yeah. And then you can just, so the base would be pi, and then you just, so radical 13 pi.
So the height of our cylinder here is radical 13. Since my radius is actually 1, the base area is pi. So my volume just becomes radical 13. So now if you don't like leaving things in terms, this will really goof you up because now we're leaving it in a radical term and in terms of pi, meters cubed.
Can we write pi at the beginning like that or?
Now why do they have 3 pi?
They do radical.
Radical 13 is not 3.
Oh, yay! I had it, Jacob.
I wrote 3.
And then I crossed it out.
What happened, Mackenzie?
Because that's the height. It says the height, not like the length. Because no, because they use like the 3 meters because that's the height of it, not that's not the length. Oh, that was L. That was
We needed to use
That was L, not
I know, you totally did.
That's and you had 13 pi there the whole time.
Perspective will play tricks on you. So that's where this gets hard. When you have a tangible 3D object to hold and you can measure or you can look at, things are easier. But here, they're referencing that the height of it is just 3. Not that we have to solve it. So that is like a trap door. We don't have to do any of this Pythagorean because the 3 that they give us is supposedly the distance from here to here. That is 3.
But then why did they put the
Why would they put it out there?
Yeah,
Chris is mad.
it's just the perspective. They're trying to show you vantage.
I thought
Why did they put
it
it on?
They better not put that on like DOA.
Wait, what is with the done? I still mess with us. What did the 3 meters correspond to again?
The height of the cylinder.
So it doesn't have anything to do with the dotted line.
Right. It's trying to show that the distance from here to the distance here, but it just shows it poorly. So all that to say, if and when you see this on your homework or a mastery, that's how they notate it. That's how the Pearson book notates it. Emily?
A good way to think about it is like you have like a stack of quarters and you like shift it to the side, it's still gonna be the same volume as if you have it like right.
Yeah, that is a good analogy, a way to think about it. Yeah.
Kids from the last class left these notes.
Yeah, I know. That's their problem. They'll figure it out hopefully eventually. No, I mean if you want to put it in the yellow bin, you can. That's where the lost and found is. Are there really any other options? I'm just gonna chuck it. Find the volume of a composite figure. Takes us. Oh, you signed me out. It always happens in this class. Because I've been on all morning. Try the next one. Be careful what the base is. Notice what I wrote into your notes. When we have a composite figure, your base is going to need to be comprised of both types of shapes. Or all types of shapes that are there. So both is assuming there's only 2. There can be more than 2 types of shapes.
Wait, this looks like Henry's fish tank.
Well, there you go.
That's really cool. Like, I'm not even kidding.
If you have Instagram and you follow Henry, everyone knows what Henry's fish tank looks like.
That's very true.
HG fish guy.
Dude,
Oh, he posts-
in this.
All right.
He's a
So
savage.
Henry's fish tank.
He's
We'll
a
just go ahead and
savage.
say.
Henry's fish tank. Henry's a real savage on this.
Now, here's the thing. I think I put this on your notes, but if we only knew that this was 48, are we able to solve this?
No. Wait.
Well,
Yes.
No, we cannot.
What if I tell you this is a semicircle?
yes we can.
Yes, we can.
Why, Greg? Since you're going to spout out that we can.
Jacob, why can't we?
No, not Jacob.
Well, because
Mackenzie, you want to help him out?
they give me the radius right there. That's
No,
why.
they don't.
Yeah.
I gave you the radius on the paper, but if you didn't have any other information, Mackenzie,
You know that 24 is the diameter, and then if you divide that by 2.
24 would have to be the diameter. So therefore, this distance would have to be 12. So, you're only saying that because I put it on your notes.
Hey, true fact. Henry's fish tank is like 21 gallons. I think.
21.
Did he post
You
that?
had to say that, man. You had to say
5.5 gallons.
What?
Like every other photo that Henry has is a fish tank.
Henry's.
It's actually pretty.
You guys, can we stop talking about fish and do math?
But there was a fish tank.
What? We are doing math. There was a fish tank.
Greg, I just said.
This is the point when the pencils.
What is a popular volume of the computer?
So to say it again, I'm probably a lot more patient than you guys, and I don't have homework to do. I don't need the time at the end of this class to get a head start on things. So when you waste our class time, you're only really annoying your classmates. And you're only really hurting yourself and your classmates. The more time we have to stop and wait for people to get back on task, the less time you have to start your homework. Some of you really need that time to start your homework because you've been turning in homework that frankly sucks. When you do 5 of the 20 some problems, you really think I'm not going to notice that? So if you want to keep getting check minuses and keep having stuff tossed up on math, whatever. Keep doing crappy homework. If you'd like the time during class to get stuff done, be quiet so we can get through the lesson. So yes, on your notes, it tells us the radius is 12 based on the diameter being 24. You have to use a base that uses both shapes. So my base is now this combined structure. Take your base and break it up. If this is 12 inches, then the amount of inches I have left right here
36.
have to be 36. So now I've got 36 by 24 for that rectangular portion of the base. So I'm going to say big B sub 1 and then big B sub 2 to find the combined big B. So when I do the 24 by the 36, what area do I get?
What?
I'm looking at this big B right now to be big B1.
864.
So big B1 is 864. Big B2, this is where I see most mistakes. You'll find the area for the circle and forget to half it. So when you have a semicircle, make sure you half it. So pi r squared, radius is 12, so we have 144 times pi, but we have half of that. So we really have 72 pi. So now this is where it gets funky. You can't use terms of pi. You can't use terms of pi if your other value is a constant, is just a whole number. So we need to go ahead and evaluate. 72 pi is approximately 226. So then I combine 864 and 226. Find out that your combined big B 1090. 0.19. So really if we went around, let's just do 0.2. Then take that times the height, because it's the height for both of them, which is 24. So to find volume, we just take 1 times 24, which is going to give us
26,164.6, or 4 rounded to the nearest 65.
Yeah, I'll go to the tenths place. And then inches cubed. Or you can say cubic inches. Emily? Yeah, so Emily asked a great question. Can we just take the volume of the rectangular portion of the tank, so this whole section, and then find the volume of the semicircle portion, this whole section, and just combine them together? You totally can. It's just, instead of doing this plus this, then times 24, you just do your 864 times 24, get volume 1. Do your 72 pi times 24, get volume 2, and then combine them together. Yep, it would totally work.
Can I see some
Sure. I'm going to drag these off to make it a little bit clearer. All right, Straddle, are you done with it?
Top of semicircle.
I'm done.
Is the top a semicircle?
Yeah.
Okay.
So this is when using sub notation gets convenient, because when you're breaking up the composite figures, it's nice for on your work to be able to use sub notations, because you guys, I doubt, are using multiple colors when doing your homework. This is one of the only times when I was in high school that I liked using a pen, because I had a 4-color pen and I would just switch colors with composite shapes. So if that helps you, colors really help my brain keep things situated.
Can I try 4.55 plus 36?
Yeah, but do you want me to evaluate 4.55 and make your life easier?
Sure. I got rounded up to 50 inches.
It's 14.137.
Should I just
So
do
really,
14?
I'd just go with 14. So then it's just 14 plus 36. So then that's an easy 50.
And so then volume.
I haven't seen a
Yes.
floss.
Yeah, like a lunch pail.
Yeah.
Yeah. Like old school.
Like a stereotype for like construction workers.
Yeah, or factory workers, because they were made out of metal. And they normally had a thermos that would go with them. What do you mean, what? Question? Yeah, because your combined base area is 50.
He simplified early, senor.
Then what'd you get?
I got 500.
You got 501.
If you don't round your base of the semicircle, it was like 14.1371669. So then if you add that with your 36, and then you multiply that by your 10, you get like 501.
Yep.
Yeah, 501.4-ish. All right, pulling up your homework.
Woo, let's get it done.
What it was 9-2 homework.
No, this is 9-3.
Sorry, that's 8. I don't know what I'm doing.
Oh, you're gonna.
No, last night's homework that you guys had a couple questions on.
Henning is a savage.
Dude, tank update. Nothing's dead.
What?
All right, so which one's the ones at like the end?
It was hilarious when you posted that picture.
You had asked me. I see what the confusion was, Greg. You'd asked me about 9-1 for those rotating problems. That's where I got confused.
What did I do?
You never came and talked to me about yesterday's. You talked to me about 9-1.
Yeah.
That's where I was confused. All right, so what questions do we have here? So if you take, so about the line y equal to 5, that'd be this line here. It would rotate up and around. It's gonna make a cylinder missing a cone. Because if I take, try to imagine with me.
My mom had to actually cut out a triangle on paper and attach it to a piece of string to help me visualize.
Yeah, because that's visualizing.
Well, that was yesterday.
So if you can imagine taking a triangle and then spinning it around, and what 3D shape you'd end up getting, well, the point of the triangle being in the middle makes it concave down in. So you're essentially going to take what cone would it have made, what cylinder would it have made, and find the difference. Which, if it's about the y-axis, it makes a cone, but not the cone we're talking about. If it's about the x-axis, this problem 22 is the amount that the cylinder in 24 is missing. So if you think about if it made an entire cylinder, that would be a radius of 4. So this radius right here is 4. And then the height of it is 2. Yeah.
One thing in 22, it's including the base, though. I don't think it's included in 24.
What do you mean? It's
Because,
including
like,
the base?
Because like the base of the cone in 22, it has to be included, but in 24, like it's just open space.
Right. Oh, sorry, my brain has already shifted to volume. Yeah, so we just have to find yeah, so we have one base, we have the outer edge, and then we have, so this portion, which is very hard, I'm just going to get out the sheet, it's very hard to think about. We have that pi RL. So think about it like this. If you have, these haven't been open for over a year. Not over a year. So, get rid of this. It's gone. You have the bottom of the cylinder, the sides of the cylinder, and then from a cone, get rid of the base, and you only have the lateral area of the cone in there. So, we have one base, we have the side area of the cylinder, and then we have the lateral area inside of here. So to answer 24, it's big B plus 2 different lateral areas. And this lateral area from the cone is the pi RL. So we would need to know what this diagonal distance is, which we know this is 4, the height is 2. So it's a right triangle with legs of 2 and 4. So this would, my L, my cursive L, is the hypotenuse. So it'll be 16 plus 4, so radical 20. So it'd be like 2 radical 5 for my L, my slant height. Is that making sense, or is anyone still completely lost? You totally lost? So, take this portion, only one of them first. So we're going to do a big B. So big B is going to be pi times radius squared. Now the radius is 4, so it'd just be 16 pi. You with me for big B? Then the first LA, we're going to say LA sub 1, is the sides of the cylinder. So that's this that I've marked off with the red vertical lines, and then all the way around the back, but you know, we wouldn't like actually see that. So that will be like the rectangle that deals with the circumference times the height between the bases, which now that is our 2. So it's going to be the circumference times the 2. Well, my circumference, pi times diameter, my diameter is 8, so that turns into 8 pi times 2. So really just 16 pi. So that's my first lateral area. And here's where it gets hard. The last thing to deal with is the fact that this pokes down in. So when you looked in on it, it would just look like that, like a concave. Like it's the outer of a pier or a cone, but just inverted. So to do that, we'll call it LA sub 2. That's the pi R L, with L being the slant height. Our slant height is the hypotenuse of that right triangle. So we get 2 radical 5. You cool with how we got that slant height? So then it's really just pi times my radius is still 4 and my slant height is 2 radical 5. So this would become 8 radical 5 pi or something crazy like that. So actually, let's look at the answer key and see exactly what they have. I'm going to stop recording before I